Hello everyone, welcome to the world of data structures. Today we are going to learn about the stack implementation using linked list. Hi, this is our instructor Janice Shah. So let's begin with today's outline, students. Today first we are going to learn that concept of the stack. We already learned about the stack, but I'm just going to revise the concept of the stack and two basic operations of the stack like push and pop. We are going to do it using linked list. So today we are going to implement stack using linked list. Student, if you remember, I already told you that any data structure like stack, queue, tree, graph, each and every data structure can be implemented by two unique data structures. They are array and linked list. Whatever we studied in the stack, whatever we studied in the queue, that's all about the part of the implementation using array. At the time we are using an array, a situation where array is a collection of homogeneous elements where each and every element has a continuous memory location. Like if first element has 1000, the next must be 1 number 0, 2, 4, 6, 8, 10. But here in linked list, it is not like that. Okay. Here we cannot write, sir, top is equal to top minus minus. No, students, you are wrong. You cannot write like that. Okay. What do you need to do? Let me show you in this algorithm push, which is stack operation implemented by linked list. Okay. So let's see. So the first, this is my stack using array. You can see it's a continuous memory allocation over there. But let me convert this stack using array into the linked list. See, I have the elements like 10, 40 and 50. 10, 40 and 50, my 50, the top pointer is pointing at the 50 right now. Okay, but how we can convert this into the linked list? Let me show you. See, this is a form of the linked list. Okay, this is the form of the linked list. Whatever the data element you have inserted first, okay, then it is pointed to the null. Then the top will be incremented and you just need to insert a new node at the beginning of the linked list. So it is similar kind of a linked list algorithm in which you are inserting a node at the beginning. That means at the first. Okay. So whatever the algorithm you have performed for the linked list insertion first, that is the same algorithm you need to perform for the push operation. Okay, so let's begin. So here let me just convert this linked list into the stack so you will get the better idea how we can represent it. So here it is, my stack. The first value is 10, then I have the 40, and then we have the 50 with us. There is no further elements are there, okay, because in linked list we are using only that much memory that we want. Rest of the memory are there in the rest of the unused memory are there in the availability stack. Whenever we want, we just take the node from the availability stack, insert it, use it, and when the use is completed, then we just return back to the availability stack again. So with the same concept we are doing over here, that 10, 40 and 50. Now let me know which one is the topmost element. 50. So right now my top pointer is pointing over here. So now you just connect your ability stack with this stack. That avail is a topmost pointer which always pointing to the topmost element of the stack. The top is doing the same. Fine. So right now my top pointer is pointing at 50. So let me know what I want to insert something over here. What I want to insert over something over here. I just need to get a new node from the ability stack, put it over the 50. If this is 50, okay, so put it over the 50, and then I just need to connect both of them. Okay, we are going to do the same thing in the push operation. Let's see how. So students, the next topic is the push operation by using linked list. So here it is. I am just giving the same as the linked list insertion at first. Yes, I already told you about it. This is my 50, 40 and 10. 5 and 3 elements are there. If I want to insert push X over there, so first I'm going to show you the representation by push operation by linked list. Okay, so here it is. We just need to take a new node. Okay, I already get a new node. How to take a new node? Right, first check whether the new node is available or not. Okay, like avail, if avail is equal to null, then availability stack is underflow. You cannot insert a new node in this stack. Fine. Second step, avail new is pointing to avail. New is pointing to avail. Third step, avail is pointing to link of avail. Avail is pointing to link of avail. So by using these three common steps, you can get your new node from the availability stack. And now just put it over here. Put it over here on the top of the 50. So what we need to do is we just need to connect. See, this is 50, this is X, this is X. Okay, I just need to connect the link of X to 50. Okay, name of this node is X, name of this node is top. So link of X is connected to top. This is my first step. This is my first step. Okay, so link of X is connected to top, but here the value is X. Value is X. Okay, but the node name is new. So we need to write link of new arrow top. Link of new arrow top. Fine. Now after linking new to top, what we need to do is which one become our topmost element? New. So just move top to new. So the second number step is move top to new. Here it is. Top arrow new. So this only two single steps you can do perform the operation of push by using linked list. Let's check out the algorithm of push. Okay, let's see. So first three common steps I already told you about it. Okay, I'm not going to revise it again. All three common steps are there of the taking the new node from the already stack. Now the next step is just bring the link of new to top. First initialize the info of new. Okay, I just forgot it. So info of new, that means info of new arrow X, then link of new arrow top, and the last step is top arrow new. So top is pointing to new. See, link of new to top, and top is pointing to new. Fine. So this is how, students, you can perform the push operation using linked list. Now let's talk about the pop in stack. So here it is, students, the pop operation in stack. Okay, so deletion at first is similar as pop, because if you remember in stack, that means last in first out. Remember, stack, that means last in first out. Whatever you inserted last is the first value which is going to be out from the stack. So here what we need to do, we just need to delete an element from the top of the stack. Okay, so it is, we have 10, 40, 50. We have 10, 40, 50. So instead of top minus minus, please don't write like that. So just do top minus minus, it will happen. No, this is not array, this is a linked list. This is a linked list. We cannot write like this top minus minus. We just need to move our top pointer from one node to the node below it. Okay, by linking. Okay, so what happens over here? We just need to write only one step, student. If we just need to write only one step, and that is top is equal to link of top. Top is equal to link of top. Top will go down. But before removing that, we are going to assign a temporary pointer over there, because after removing a node, we need to move it to availability stack. Fine. So first, I need to initialize the temp over there, like temp arrow top. So here it is, the first step, temp is pointing at top over there. Okay. In the second step, top will pointing to link of temp. So this is temp, this is link of top. This is temp, this is link of top. Your all operation is completed. See, now the stack is known as from null to top 50. It is not in the stack, it is already out of the stack. You can remove it. Fine. This is my temp. I need to just restore it into availability stack. This is how, students, the pop operation is completed. And when I'm talking about the algorithms, here it is. It's a very basic steps. Okay, the first step, you need to check out whether my stack is there or not. Okay, so here in stack we have the top pointer only. So just talk about the top pointer. Here, please don't write like that. So top is equal to 0, that means stack is empty. No, students, this is a linked list. So just write top is equal to null, that means stack is underscore. Second step, if stack is not underscore, if you want to delete something, then just do top is equal to the first initialize temp to top. First initialize temp to top, and then do top arrow link of top. Top arrow link of top. So first temp is pointing to top, then top will point to link of top. In the last step, restore temp. Restore temp, this step is known as to move temp node, temporary node to the availability stack again. Fine. So this is how you can perform the push and pop operation. I hope from this you can easily perform the change and peep also. So students, if you have any doubt in this stack implementation using Makelist, then please feel free to ask me. Thank you so much.